Let's take a look at some basic time value of money principles. This is a review of time value of money, so we're going to go through a lot of basic things. First, let's talk a little bit about what is time value of money. Remember, time value of money is simply preferences. Do I want more later? Do I want more now? Do I want less later? Do I want money sooner versus later? So we answer a lot of questions with basic time value of money. Questions you may ask yourself is, what will I want my investment to grow to? Or how much money do I need today? Or how fast must my money grow? Or how long will it take? So these are the types of questions that we can answer with basic time value of money. There's a difference between simple and compound interest. So time value of money is calculating for compound interest. Simple interest is simply interest earned on the principal only. So think of it, it's a simple calculation. Compound interest would be interest earned on principal and any unpaid interest earned in an earlier time period. Here's the formula for the basic simple interest calculation. So you can see here future value equals to our principal times the interest rate times the number of periods, and then add back our principal. It's a pretty straightforward calculation. An example would be as follows. Assume we have principal of $1,000, an interest rate of 10% in a term of 5 years. After 5 years, how much money would I have? Well, I would take the 1,000 times 10% or 0.10 times 5 and then add back the 1,000. And what do I get? $1,500 is my future value. Compound interest accumulates interest. So that's where you earn interest on top of interest. The power of compounding is why people can end up with very large amounts of money in retirement. You can see the formula, future value equals to present value times 1 plus the interest rate to the nth power. So that's what your calculator is doing behind the scenes. This BAII plus calculator over here makes those types of calculations. So if we were going to do it longhand, what could we do? We could say 1,000 times 1.1 to the 5th power. How do I do to the 5th power? Y to the x, 5. And it didn't do it exactly right. That's a good example of calculator order. I'm going to leave this in here as a good example of how calculator order sometimes doesn't work. So let me do that again. I've got to reverse this problem because of the way that my calculator takes entry points. So I'm going to say 1 plus 0.1 equals to 1.1. Y to the 5th power equals to 1.611 times 1,000. And what do I get? $1,610.51 or $1,611. How come there's a difference between those two? Where's that difference coming from? So I get interest of $611 here. Earlier I had interest of $1,500. It's a time value of money difference. That compound interest earned on top of interest created a $110 difference, actually a $111 difference. First things first, we want to make sure that our calculator is set appropriately to where if we're taking a CFP exam, the exam for this course, or anything else, we can standardize where our calculator is set. The first thing I want to do is set my calculator to 4 decimal places. How do I do that? Well, if you'll notice, there's a format button right down here. So I'm going to push the second button in format, and it's going to say DEC equals to 2. I want that to be 4, so I'm just going to say 4 and then enter. Now my decimal places, you'll notice, are set to 4. So I can come down here and just go back, and my decimal places are set to 4. Next, I want to set my compounding periods to 1. Always do this, and the reason that I do is because if you change your compounding periods, and I've had this happen, I've taught time value of money for years, and I've had students go in and they reset their compounding periods, and the next thing you know, they're on an exam and they forgot they reset their compounding periods and all their problems are coming out incorrect. So it's better to just do the math to manually make changes rather than continually resetting your compounding periods. So if yours says anything other than 1, you'll just say 1 and enter. Now it's set correctly. Remember, before every calculation, you want a second future value that clears out the work in your time value of money keys. The time value of money keys are this row of keys right here, and that's what we'll be learning about today. I'm going to teach you a lot about special features in this calculator, and I'm going to show you how to use some specific rubrics that I think will help you in preparing to do time value of money with the BAII 2+ calculator. Okay, anytime with time value of money, I always draw a timeline. A plus or minus sign is going to indicate cash inflows and outflows. In the early time value of money problems, that's not an issue because inflows, outflows, pretty straightforward. You can screw those up and it's probably not going to make a difference. When we get into making payments and other issues with time value of money, that inflow, outflow becomes critically important. Remember that calculators use percentages, whereas Excel uses decimal places. So if I'm going to enter a percentage into my calculator, 2 is 2%. I would just say 2IY. If it was Excel, 2 would be 0.02. So there's a real difference between those two. Let's talk for a second about an annuity. So a lump sum is a single payment at time 0. That's a present value. Or a single payment at the end of time. That's a future value. Periodic payments would be payments that are made continuously. So an ordinary annuity is when a payment is made at the end of a period. An annuity due is when a payment's made at the beginning of a period. So annuities must be then in equal amounts, and they must occur every time period for your calculator to be able to handle them. So they must occur in equal amounts, and they must occur in every time period. Remember, an ordinary annuity happens at the end, and an annuity due happens at the beginning. So is this an annuity? And the answer is yes, this is an annuity. When did it happen? At the beginning or at the end? It happened at the end. So what is that? Remember, an end period annuity would be an ordinary annuity. How about this? Yes, that's an annuity. And it's what kind of an annuity? Well, let's go back. It's happening at the beginning of the period, so that's an annuity due. Is this an annuity? For purposes of our calculator, no, because it doesn't happen in every period. Since it doesn't happen in every period, our calculator cannot handle it as a payment key. How about this? And the answer is no. Because it's not equal amounts, our calculator cannot handle this. So lump sum and periodic payments, this could be a combination. There are times whenever I receive a payment that is a single payment, and there are periodic payments for the life of that investment. This is whenever we're looking at present value and payments. The recommended structure that I would suggest that you use and print out is as follows. This will keep you from making mistakes. For the rest of this lecture, I'll use this recommended structure. I suggest if you were to take an exam in an online setting that you print out a bunch of these and use them to draw out every single time value of money problem you may come across. Let's look at an example. If I invested $1,000 into a savings account earning 10% compounded annually, how much will I have in 5 years? So what's in our problem? We have a present value of 1,000. We have an annual rate of 10% in 5 years. I'm solving for future value. So the first thing I want to do in my calculator is to go in and say second future value. That clears out everything associated with time value of money. Next, I'm investing this $1,000. So I'm going to say 1,000, and I'm going to make it a negative number. It's a cash outflow. It's an investment that leaves me. I'm going to put that in as a present value. My interest rate is 10%, so 10 is my IY. And this is happening over 5 years, so 5 is my N. I want to know the future value, so I'm going to compute for future value, and what do I get? We've already worked this problem, so we know the answer. It's $1,610.51. Let's say, though, that I invested $10,000 into a mutual fund, expected to earn a 12% compounded after-tax return. How much would I have at the end of 50 years? Well, what's going in here? It's $10,000 invested today, put in there for 50 years, annual rate of 12%. First thing, clear time value of money. So my time value of money is cleared. I'm going to invest in here $10,000 cash outflow as my present value. The interest rate that I can earn is the going market interest rate of 12%. And this is going to happen for a long time. So I'm 18, I put money in, and I'm going to put it in until I'm 68 years old. That's a long time. How much would I have? You can throw out a guess. $2.89 million. $2.89 million. That's a ton of money. Why is that number so large? How does 10,000 become almost 3 million? Because of this power of compounding. That's the key here, is time value of money. Money has value across time, and it is that investment that is huge across time. Let's say that I invest 10,000 at the end of each year in a mutual fund, expected to earn 12%. How much will I have at the end of 5 years? Something's changed. What's changed about this problem? At the end of each year. So I want to clear my time value of money, and let's see what my problem has in store for me. 10,000 is going to be my payment. It's an outflow, and it goes in as a payment because it's happening every year. 12% is my interest rate, and 5 is going to be my number of years. I'm trying to determine the future value, and what do I get? I get $63,528.47. What if I invested $10,000 at the beginning of each year in a mutual fund expected to earn 12% compounded after tax? How much am I going to have at the end of 5 years? Notice, same problem, only one thing's changed in the problem. I could go back and I could re-enter this, or I could go and I can set my calculator to beginning. How do I do that? You'll notice right above the payment key there is something that says BGN. So I can say second payment and then second enter. And notice my calculator now changes to beginning. I could then go and recompute. I should be able to go and recompute my future value, but somehow my numbers got cleared out. That's okay. So let's just clear our time value of money and start over. Let's say 10,000 again is going to be my payment. So I have a payment that goes in as 10,000, but I messed up. What did I not do? It's a negative number. It doesn't matter for right now, but I promise you, getting in the habit of doing this will make a difference down the road. So my payment is negative 10,000. 12 is my IY, and then 5 is my N. Compute for future value, and what do you get? You get $71,151.89. Notice you're earning a little bit more money. Why? Because it's a beginning versus ending. You can see that here. So this ordinary annuity, when the 10,000 went in at the end of the year, I ended up with $63,528.47. But if I put the money in at the beginning of the year instead of the ending of the year, instead of the end of the year, it has more time to compound. With that additional compounding time, I turned $63,528 into the $71,000. So you can see the value of money across time here. What if I invested $10,000 a day and $1,000 at the end of each year in a mutual fund expected to earn 12% compounded after tax? How much am I going to have at the end of 5 years? Again, let's clear our time value of money. Does it say anything about beginning? No. So what do I want to do? Second payment, second enter. I've now set that into, and I don't actually have to say second enter, I can just say enter. So I've set that number into, or I've set my calculator back to ending mode. So let's look here. I have 10,000 invested today, and this is where outflows and inflows are important. So I invest 10,000 today, present value. And let's say I forgot to clear my time value of money, or couldn't remember if I cleared my time value of money. I can still do it. Second FV, and then all I got to do is push the present value. Now, 1,000 is being invested every single month or every single period, so that's going in as a payment. 12 is going to be my interest rate, and 5 is going to be my N. Whenever I compute for future value, what do I get? I get $23,976.26. We can see here what that looks like laid out whenever we're running the manual calculations. This is the way you would probably do it, or one of the ways you could do it in Excel. Times 0, I put in 10,000. That has a future value across those 5 years of 17,000. And then pulling forward each one of these $1,000 payments and summing those up, I get the same exact number. Okay, time value of money can also solve for rates of return. So what rate of return is required for 10,000 to grow to 16,000 in 5 years? This is where things become important when we're talking about cash flows. I'll show you what I mean. So let's take 10,000 and make that our present value, because that's what I'm putting in today. Let's take 16,000. Oops, put too many variables in. What do? I can push this little back arrow, make that my future value. I purposefully made an error right there. Let's take 5 and put it in as my n. Now let me compute for IY. What does it do? It says error 5. I get students all the time saying, my calculator says error. I don't know what I did wrong. What you did wrong is you have to have a cash inflow and a cash outflow when you have a present value and a future value. So let's clear our time value of money, and let's do this problem correctly. I invest $10,000 today, present value, to receive $16,000 in the future value. This is done over 5 years, and whenever I compute for IY, what do I get? I'm getting 9.8561. That's the rate at which I would need to earn my capital would need to earn me to turn 10,000 over 5 years into $16,000. Let's say I invest 2,000 at the end of each year for 5 years. What rate of return must my investment earn if I want to have 16,000 at the end of that period? So let's take a look. Second time, clear time value of money. I'm investing $2,000 at the end of each period, so it's a cash outflow. It's a payment because it's done time and time again. 16,000 is the future value. It's what I will someday receive. 5 years is the time period, and whenever I compute for IY, what do I get? I get a credit card rate of return, 23.69%. Would love to get a rate of return like that. One little quick aside here is there's a kind of quick way to check your numbers if they seem far out of kilter. Just do an ocular exam test on this. So how much money went in? I put in $2,000 per period, 5 periods, so 10,000 went in and 16,000 comes out. 23% seems reasonable to me. That's a reasonable rate of return to equate those two to one another. If my number came out 7,000%, I would automatically know something's off. Or if it came out 1%, I would automatically know something's off. So be logical whenever you're running these problems and determining whether or not the number you got seems to make sense. Another thing you can do is you can go back into your calculator and see what numbers you've put into each one of these categories. So if I want to see what I put in each one of these, I can push the RCL button, that's the recall button, and the future value. I can recall the payment. I can recall in, and I can see what I put in each one of those slots. That becomes helpful if I forgot what I have in each one of them. Let's say I invest $10,000 today and $500 at the end of each year for the next 5 years. What rate of return must I earn to have $16,000 at the end of that period? Again, somewhat complicated problem, but not too bad. I'm investing $10,000, so that is going to be a cash outflow, and it's being done today. Then I'm going to invest $500 at the end of each period, cash outflow, $500. To receive $16,000 at some future period, and that's done across 5 years. What rate of return equates those? What do I find? 5.7064, or rounded up 5.71%. We can also use time value of money to solve for the holding period required for a present value, a series of payments, or a combination to reach a future value given a specific rate of return. So how many periods would it take for $10,000 investment to grow to $24,000 if I know I can earn 11.25%? So clear our time value of money, This is a $10,000 investment, so it's going to be a present value, it's negative. To grow to $24,000, that's what I'm going to receive in the future. My rate of return is 11.25%, so that's going to go in as my IY. And what am I computing for? Time. So I'm going to compute for N. And what do I get? 8.2119 years. So if I invested $10,000 today, and I knew I could earn 11.25%, and I needed 24,000, the time period that I would need for that to grow is 8.21 years. Let's say I deposit 3,000 at the end, or excuse me, I almost messed up. That's why, and this makes, sometimes I mess up on purpose, sometimes by accident. In this case, it was by accident. But what I want you to be careful for is whenever you are reading, you want to slow down and make sure that you're paying attention to the words that you read. What I like to do is whenever I'm working on a problem, if I have a piece of paper, I'll underline or highlight an important word. So if I deposit 3,000 at the beginning, things have changed in this problem whenever we see the word beginning, and we have to pay attention to that. It's easy to glaze over that and just assume ending periods. So I deposit 3,000 at the beginning of each year in a savings account earning 9.75%. How long is it going to take for that to reach my down payment needed of $20,000? Well, the first thing we're going to do is clear our time value of money, so second FV. And I know that I need a down payment of $20,000, so that's a cash inflow. I know that I can deposit or outflow $3,000, and that's going every year, so that's a payment. I know that I can earn 9.75%, so that's an IY. But I need to change this to beginning, and that's why, if you notice, the rubric that I use here has a little deal down here at the bottom where you can say beginning and ending while you're working on the problem. So to change this, I can go to second payment, and I need to change that to beginning, and then just set that in place. So my pieces are still in play. I can recall and see that my payment's still there, my future value is still there, and my IY is still there. All I would need to do is go in and compute for N. And what do I find? It takes approximately 5 years to grow that if I put those payments in at the beginning of the year. The way that you know your calculator's set to beginning is this upper right hand corner. Even when I clear my workout, you'll see that the beginning's still there. Even when I clear out my time value money keys, the beginning's still there. The only way to get it off is second payment and then second set. Time value money can solve for the price you would pay for a future value, a series of payments, a combination, given a specific rate of return. What would you pay for the right to collect $8,000 in 7 years if your required rate of return is 8.75%? So I want to collect $8,000, clear my time value of money first. So I want to receive $8,000 in the future. I know I can earn 8.75%, which is my IY. I know I have 7 years of time. How much would I pay for that? So I'm computing for my present value. And what do I see? $4,447.18. What would you pay for the right to collect $8,000 at the beginning of each year for 7 years if your required rate of return is 8.75%? Practice this yourself. Pause this for a second and practice it on your own and see what you get. When we put this into our rubric, 8,000 is our payment, 8.75 is our rate of return. Remember to set your calculator back to beginning, so that's second payment, second set. Calculator is now set to beginning. 7 is my N, and whenever I calculate for the present value, I get $44,156.42. What would you pay for the right to collect $800 at the end of each year for 7 years and an additional $10,000 at the end of the period if your required rate of return is 7.25%? Well, let's see. Second, clear time value of money. I'm set to beginning, but this says end. So I want to say second payment, second set. reset my calculator. So what would I pay so that I know I'm solving for a present value for the right to collect? So that's inflow, 800. So I want to, one more time, clear my time value of money. 800 is going to be collected at the end of each year, so it's a payment. At the end of that time period, I'm going to collect 10,000. That's my future value. 7 is going to be my in, and 7.25 is going to be my IY. What would I pay for that right? I would pay $10,400.69, rounded up to 79 cents. Time value of money can take into account compounding periods shorter than 1 year. I do this in a very specific way because I've found over the years with students taking exams and nationalized exams, the CPA, CFP exam, setting the calculator up in the way I'm about to show you is the most efficient way to make sure that you do the problems correctly. So if compounding periods are less than annual, that is, there are multiple compounding periods, it's going to cause the effective interest rate to be higher, which means that the future value is higher and the present value is lower. The formula that your calculator is then going to be using is as follows. Future value equals to present value times 1 plus the interest rate divided by the number of compounding periods raised to n times the number of compounding periods. So to make the adjustment, with the compounding periods, I have to divide my rate by m and multiply my years by m. So let's look at an example. If I invest $6,000 into a savings account earning 10% compounded quarterly, how much will I have after 5 years? So what do I need to do? When I look at my sheet here, and this is where I think you'll find the rubric to be even more important, you can see I have a present value of $6,000. That doesn't change. My annual rate's 10%, and my number of years is 5 years, but I want to know this on a quarterly basis. So what are the number of compounding periods in quarters? Well, there are 4 quarters in a year, so 4 goes in here. So what is my rate per period? I need to take the 10% and I need to divide that by 4. That is going to give me 2.50%. For my number of periods, I need to take the number of years and multiply that times compounding periods, which is going to be 5 times 4 or 20. So now I can use this with my time value of money calculator. I can say 5 times 4 equals to, and drop that right into my in slot. I can say 10 divided by 4 equals to, and drop that right into my IY. I wouldn't just write that number down, because if you write that number down, you can have some transcription errors. When I calculate it, I drop it right into the IY slot. 6,000 is a cash outflow. It's negative. It is a present value. Now I can go in and I can compute for the future value. And what do I see? $9,831.70. If you invest $1,000 in a savings account earning 10% compounded daily, how much would I have after 5 years? Again, we have multiple compounding periods here. Let's clear our time value of money. Present value doesn't change. I'm going to invest $1,000. That is a present value. I have an annual interest rate of 10%, but this is done over 365 days. So I need to take that 10% and divide it by 365. Whenever I do that, I get 0.0274%. So I take that 0.0274% and immediately drop that into my IY. That'll keep you from making transcription errors. Next, how many days are there in that period? I'm going to take 365 and I'm going to multiply that times 5 years, drop that right into my N. Now compute for future value, and what do I get? I'm going to get $1,648.61. If I invest $1,000 at the end of each month in a mutual fund that is expected to earn 12% after tax return, how much will I have at the end of 5 years? These problems are starting to look more and more realistic. This could be something that could easily happen. So what do I want to do? First, second, clear time value of money. I invest $1,000 at the end of each month. It's a payment, it's an investment, it's an outflow. So it's done every single month. I can earn 12%, but that's 12% a year. I need to know how much I earn per month. So I'm going to take that 12 divided by 12, or the number of compounding periods. That's going to be my IY. Next, I'm going to take 12 compounding periods and multiply that times 5 years to show that there's 60 compounding periods. 60 is my N. Now, how much am I going to have after this period? Compute for future value, and what do I get? $81,669.67. Uh-oh, we have a beginning problem. So what do? I need to second payment, second enter. Now I'm set to beginning. I can clear my time value of money. What if I invest $1,000 at the beginning of each month in a mutual fund earning 12% for the next 5 years? So this is done every single month. $1,000 cash outflow invested. It's a payment. I'm going to earn 12%, but remember that is my annual. I need to make that monthly. So I'm going to take that 12% and divide it by 12 and drop that immediately into my IY. Next, this is done over 5 years. So how many compounding periods are there in 5 years? There are 60 of them. And I want to compute for future value. And what do I see? $82,486.37. Notice that was different than the number earlier because of the beginning time period. If I invest $2,000 at the end of each quarter for 5 years, what rate of return must my investment earn if I want to have $60,000 at the end of that period? Well, this is done at the beginning, so I need to reset my calculator to ending period, and I want to clear my time value of money. Okay, so I know that at the end I'm going to receive $60,000. That's a future value. I know that I'm going to invest $2,000 cash outflow every single period. So that's going to go in as a payment. I know that this is done over 5 years, so 5 normally would be my end, but it's not. Why? Because this is done quarterly. So how many quarters are there? 5 times 4. So there are 20 quarters. So what do I want to compute for? When I compute for my IY, what is this telling me? This is what I see people put on an exam many times. They put 4.07% is the rate of return. But what is that rate of return? That is my quarterly rate of return. How do I make that an annual rate of return? I need to multiply it times the number of quarters to turn it into an annual return. And I get 6.2860. If I invest $10,000 today and $500 at the end of each month for the next 5 years, what rate of return must I earn to have $60,000 at the end of that period? Why don't you stop the recording right here and practice this? This is a tough problem. So practice it and see if you can get it correct. Okay, so let's put it all in. Second, clear time value of money. I know that I'm going to grow this money to $60,000 in the future. I know that I'm going to invest $10,000 today. It's the present value. I know that I'm going to invest $500 at the end of every month. That goes in as a payment. Next, I know that I'm going to do this for 5 years, but this is done monthly, so I need to take that 5 and multiply it times 12. There is my N. Now what do I want to do? I want to compute for my IY. What have I got right there? What is that IY? That is my monthly compounding rate. That is my interest rate per month. But I want to compare apples to apples, so I need to standardize this by turning it into a yearly rate. How do I do that? Multiply it times 12. And what do I get? 12.4958 or 12.5%. If I deposit $300 at the beginning of each month in a savings account earning 9.75%, how long will it take for me to save for a $20,000 down payment to buy a home? Well, let's take a look. So this is done at the beginning. So I need a second payment, second enter. My calculator is now set to beginning. So I know that I'm going to do the following. I'm going to deposit $300. That's a cash outflow at the beginning of each month, so it's a payment. I know that I want to save for $20,000. That's going to be received in the future, so that's a future value. I know that this is done monthly, and I know that I'm going to earn 9.75%. So 9.75 is my annual rate, but I need to make that monthly. So I divide that by my number of compounding periods and drop that into my IY. You can see that rubric laid out here. Next, whenever I compute for my N, what do I get? I get 53.14. That's not the number of years, that's the number of periods. So how do I turn that into years? That's the number of months. So divide by 12, and I get the number of years, 4.4284 years. So again, in reviewing, we've looked at simple interest, compound interest, all the present value, future value payments in and IYs, and we've calculated on a multi-period basis. You need to know how to do all of these. I would suggest, we ran through this kind of quick, if you need to, pause each one of these slides and practice on your own trying to come up with the answers that I came up with.